This will be for the con exercise, interpreting trigonometric graphs in context. So all of these problems have a write-up and then a graph and 2 questions. Before I read the write-up, I like to answer the first question. Okay, the first question is easier than the second one. Anyhow, we have this sinusoidal function, and they're going to ask us what this dashed line is. We can clearly see that this dashed line is the midline, okay, and that is the horizontal line that is right in the center of the max and the min. So, which feature of the graph corresponds to the highlighted segment? That's this dashed line, and that is the midline. All right, and then they're going to ask, what is the meaning of that segment or the midline? So I think your best bet is to draw a little sketch. So it says Cody is observing a roulette turning. The horizontal distance between Cody and the number 0 on the roulette in meters is modeled by d of t, where t is the time in seconds. The function is graphed below. All right, so we have a roulette wheel, and that graph is the distance between Cody and the number 0. Let's see. So this is the distance between Cody and the number 0. So I'm going to draw a roulette wheel. Okay, you can do this on your paper. And the person's name is Cody. I'll just draw a C for Cody. Okay, and when the 0 is here, the distance between Cody and the 0 is 1 unit. Okay, so from here to here is 1 unit. Okay, and when the 0 is furthest away from Cody on the other side, let's say right there, the distance between Cody and the furthest point of the 0 is going to be 2. All right, so the closest distance is 1. The furthest distance is 2. So the 1.5, that midline, would be the distance when the 0 is basically here or here. So this 1.5 represents the distance from Cody to the center of the roulette wheel. This distance right here would be 1.5. Okay, so that's it. There's not much to calculate on these. You basically have to figure these things out. All right, so the first one we said was midline. The follow-up question, Cody is 1.5 meters from the center of the roulette. All right, you can certainly check the other ones. This one says the radius. That would only be from here to here, not the distance to Cody. And this one is based on time, since it's in seconds. This is diameter, so it's definitely answer A. So it's A on both questions. All right, again, I read the write-up after the first question. All right, so here we have a sinusoidal function, and this highlighted segment is clearly the distance from one max to the other. Okay, the horizontal distance from max to max, this is going to be a period. So which feature corresponds to the highlighted segment? That is a period. All right, the period questions are actually easy. Kai is swinging on a trapeze in a circus show. The distance between Kai and the edge of the stage in meters is modeled by d of t, where t is the time in seconds. Okay, so you can see the x-axis is time, and the y-axis is the distance between Kai and the edge of the stage. So he's basically swinging. All right, if I were to draw a rough sketch, he is basically swinging back and forth on that trapeze. All right, so let's say the stage was over here, And over here, he is farthest away, so this would be the max distance. All right, so if you take this highlighted segment from max to maximum, that is the time for him to swing from the max to the min and back to the max again. All right, so it's basically the time for him to swing one cycle back and forth. So that's all that is. All right, so that is a period. And the meaning of the highlighted segment: Kai completes a single swing cycle in 10 seconds. It has to be this one because this is based on time. Okay, this one is based on a distance. This one is how many cycles. This is how long the trapeze is. Period. A period is a horizontal distance here. See that? And the x-axis is based on time. So the answer for the meaning of the highlighted segment also has to be based on time. So answer C and answer A. Okay, so I go right to the first question here. They're going to ask us for this highlighted segment. So this is half the distance from maximum to the minimum. So this is basically an amplitude. Okay. That's an amplitude. And it says, Macy is observing her young brother riding the carousel. The horizontal distance between Macy and her brother is modeled by this function. All right. So let's do a little sketch. So let's see. We're going to draw a carousel. All right. And we have Macy observing the brother riding the carousel. Okay, so this is Macy represented with M. The brother is going to be represented with a B. Okay, the minimum distance between the two is 6 meters. I'm assuming that's in meters. So, like from here to here is going to be 6 meters. All right, and when the brother is furthest away on the other side of the carousel, the distance between Macy and her brother is farthest away, and that distance is going to be 14. All right, so the closest they are is 6 meters, and the farthest apart they are is going to be 14 meters. So what's this distance right here, the amplitude? Well, I'm thinking if we took this line here and drew it on the circle, that would be the distance from the edge of the carousel to the center of the carousel. So this, to me, looks like a radius. Okay, it's either a radius or perhaps they're going to say the distance between the brother and the center of the carousel. So that's probably what they'll say. Let's take a look. All right, so we said this is an amplitude. Highlighted segment, carousel completes 4 cycles. No. Macy is 4 meters from the center. No. Macy's brother is 4 meters from the center of the carousel. Yeah, that's it. Okay, like we drew here, the brother is 4 meters from the center. Answer D is completes 1 cycle every 4 seconds. No. So this is it right here. All right, so answer B and answer C. All right, I go to the graph first here, the sinusoidal function. They're going to ask us what this is. Once again, this is a midline. All right, so that's a midline. And then they're asking what's the meaning. So let's draw a sketch. All right, piece of gum is stuck to the tire of a bike. Vertical distance between the gum and the ground in centimeters is modeled by this function, h of t, where t is the time in seconds. All right, let's see. So I'm going to draw a bicycle wheel the same size as this graph. All right, a bicycle tire. And we have the ground right here. And we have a piece of gum stuck to the tire. Okay, this is 0 right here. So at one point, the distance between the gum and the ground is 0. That's when the gum is right here. Okay, and at the furthest distance, the distance between the gum and the ground is 60 centimeters. That's when it's all the way up here. So this distance from the ground to the gum, when it's furthest away at the top of the tire, that distance is 60 meters or centimeters. All right, now the midline is 30. So if the distance from top to bottom, that looks like a diameter to me. The distance from here to here is 30. And that to me looks like a radius. All right, so I'm going to say this midline here is the radius. I could have drawn it from the bottom as well. Okay, I could have drawn it like that, and that goes from 0 to 30. Okay, so that radius right there is 30 centimeters. All right, so we got a midline, and the wheel center is 30 centimeters above the ground. Yes. Okay, double check. Bike speed, no. Diameter, no. Completes a cycle, no. Okay, so it's clearly answer A. All right, so we have answer A and answer A.